This is practice A for section 6.3. This is the back of the worksheet. We're going to determine whether the triangles can be proved similar. If they are similar, write a similarity statement and explain your reasoning. So for these triangles to be similar, you need two pairs of congruent angles. So both of these triangles are isosceles. One is definitely bigger than the other. If these are the legs, these are the base angles. So this angle is definitely 71 degrees. Now I can calculate the measure of that vertex angle. I have 180 degrees in a triangle and I take away 71 twice. That gives me a 38-degree base angle. Now if you notice, over here in this isosceles triangle, this vertex angle is also 38 degrees. So you don't have to do the math again. You know those angles are 71 degrees. So these are definitely similar triangles. They want you to write a similarity statement. So I'm going to name this triangle MNO. It's going to be similar to this triangle. I started with the vertex angle. So I'm going to start with the vertex angle over here. Now here's where you have options. N and O are congruent to angles P and Q. So being that it's NO, over here you could write PQ or QP. It's not going to make a difference because the triangle is isosceles. So when you have an isosceles triangle, there's more flexibility with your similarity statement. What's the reasoning? Angle. Number 14, we have a triangle with a right angle, a 30-degree angle, so obviously we know the other acute angle is 60. And up here we have a right triangle, but it doesn't have to be a 30, 60, 90. We don't know these angles. Maybe they match these and maybe they don't. So we don't know here. Maybe they are, maybe they aren't. That's your answer. Show that the triangles are similar. Well, this one's easy. You got two pairs of congruent angles. They're similar by angle. This one, I'm pretty sure we've done this plenty of times, and if we haven't, you're going to get used to it on this assignment right here. When you have parallel lines, that creates congruent angles. These are corresponding angles. They're congruent. And it makes those corresponding angles congruent as well. So now you have a triangle inside of another triangle, and you have two pairs of congruent angles. Likewise here, you got parallel lines running. Corresponding angles are congruent because of these parallel lines. Now, these lines are parallel as well, so that makes these angles congruent. So notice how this triangle and this smaller triangle have two pairs of congruent angles. Number 22, we're going to write a two-column or paragraph proof. We're given that segment DE is a mid-segment of triangle ABC. Prove that triangle ABC is similar to triangle DBE. If we know that segment DE is a mid-segment, then we can use what's called the mid-segment theorem. We know that the mid-segment is parallel to the side that it doesn't touch. So step 2 would be saying these are parallel. Step 3 would be to then say, well, then your corresponding angles are congruent. Now, you can clearly see that those two triangles are similar by angle. So if I was to write it out, we know that's the mid-segment. So we can say that segment DE is parallel to segment AC by the mid-segment theorem. Now, if you have parallel segments, remember what we said, these angles would be congruent. Now, I don't call this angle D. You're going to have to use 3 letters. You could call this angle A, though, if you wanted to. There's only one angle there. So angle BDE is congruent to angle A. So that's these angles. Likewise, angle BED is congruent to angle C. So that's the corresponding angle postulate. We have parallel lines and corresponding angles, so they're definitely congruent. Now, this is two pairs of congruent angles in a pair of triangles, so we now know that those two triangles are similar by angle-angle. Number 23 is about an A-frame. The A-frame building shown in the figure has a balcony that is 16 feet long. So that's this guy. It's 16 feet high. That's this dimension. And it's parallel to the ground. That's really important. The building is 28 feet wide at the base. How tall is the building? So we're not measuring this diagonal piece, we're measuring this vertical piece. Best thing to do in this one is to draw the triangles separately. You have a little triangle inside of a bigger triangle. So if you would redraw the little triangle, obviously this is 16. We would like this piece, but we don't know what it is, so we'll just call it X. Now when we transfer over and we look at this bigger triangle, we know that this bottom is 28 feet. Here's the key to the whole problem. This is the height that you want. But if you introduce a new variable, you're not going to be able to solve for x. So what you call it instead is you already know that this piece of it is 16 feet. So like up to like here-ish is 16 feet. Then you have that other piece that's x. So call this 16 plus x. Now, you could write a proportion if you knew that these triangles were similar. Remember how they said that these are parallel. Well, if those are parallel, remember that creates congruent angles here and here. So these are similar triangles. So what that means is 16 to 28 is the same thing as x to, I'll just put x plus 16 even though that says 16 plus x. And then you cross multiply. We may not have done something like this in the past where you have a variable in both spots. 28 times x is 28x, and over here we get 16x plus whatever 16 squared is. I think it's 256. It is. And then you're going to solve for x. We're going to subtract 16x from both sides, and then we're going to divide by 12. Then we're going to get 21. I might as well show you. You're going to get 21.3 forever, which is 21 1/3 feet. Okay, now that's what x is. That's this distance. Now they ask you, how tall is the building? So it's 16 plus that. So I'm not real sure how to write that. We'll just say 16 plus x equals 37 1/3 feet. That's your answer.